All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about ESP32 things, and more specifically, we're going to be focusing on clock signals and understanding how the ESP32 uses clock signals in various ways. We've been making a lot of progress with this over the past few streams where I was actually, doing research on this. We have definitely been making progress, and in not the last stream necessarily, but the stream before that, we made a pretty decent amount of progress, I would say, in terms of understanding how the clock signal was being used. It was pretty interesting to learn how the ESP32 is deciding which, or rather the CPU clock is deciding which source is going to be used. And it's not even the CPU clock that's deciding. It's, I believe, to a certain extent it comes down to um, a mixture of the settings that we provide in the bootloader, which in this case would be default settings because I'm not providing anything custom yet. Maybe later on I might, but so far I'm not providing anything custom. So whatever the default bootloader settings are, and whatever the ESP32 is hard coded to do, hardwired to do, in terms of selecting certain settings and stuff. Where was I going with this? I think what I was saying is that it's the behavior is a mixture of what we decide in the bootloader settings and what the ESP32 is hardwired to do. Um, and yeah. So all of this, by the way, we've spent a couple of days doing research on this, and this whole thing started with um, trying to understand PWM, and more specifically how um, well, first of all, yeah, how PWM was being implemented, but also why, let me show you why these types of formulas were necessary. Because I couldn't make sense out of what was going on here. I couldn't understand what LEDC clock was, what the clock divider was, why these different formulas were there in place, and like I just couldn't understand what was going on. And so I kind of had to take a step back and learn all about clock signals and how the frequency is working. And it was pretty interesting. Basically, what it came down to is that the ESP32 has no notion of time. It counts time into, hold on, give me a second. Sorry, I need to open up my chat on my phone, and then we can continue. Yeah, so basically what it comes down to is that the ESP32, and okay, at least in this specific aspect, when it comes to these specific things, yeah, the ESP32 has no notion of time. I don't know if there's some other hardware in some other area of the ESP32 that does have some notion of actual time, but in this specific area, uh, what I've understood, I feel like I should make that clear now because I don't want it to seem like I don't want it to seem like what I'm saying is fact, um, because sometimes even I'm not sure about what I'm saying here, because what I'm saying is what I have understood from all the research that I've been doing. And of course, I don't want to give out wrong information. So if I'm doubtful about whether it's true or not, I'm just going to be like, yeah, this is my understanding of it. My understanding could be right. I try my best to, make sure that it's right, but it could also be wrong. So yeah. Anyways, um, back to yeah. So the ESP32, at least from my understanding, the ESP32 has no notion of time. So the way that it measures time is basically in ticks. You have a clock signal being generated. Even the hardware that is meant to be reacting to time-based events, it mainly reacts to these clock signals. More specifically, either the rising or falling edge of the clock signal. That is what kind of synchronizes um, different actions. And basically, we have, let's say we are talking about, okay, so given that the ESP32 has no notion of time and it's using these ticks, the amount of ticks per second would be our frequency. And based on that, we can determine, we can create some notion of time there, because we have, let's say if we have 80 million ticks per second, that would be an 80 megahertz frequency. If we want to know how long one tick is, we do 1 divided by 80 million, and that gives us 12.5 nanoseconds, because it's 80 million ticks per second. So yeah, that gives us 12.5 nanoseconds, or 0.000, I don't remember how many zeros there are, 25 seconds. But yeah, it's 12.5 nanoseconds. And right there, we now have the concept of time. Now we have something that we can use to time events. So it can be like, okay, I'm not sure what example to give here. Okay, let's open up Python here. Actually, do I have Python open here? Yeah, maybe I can open up Python. No, I mean, you guys will be able to see it anyways because it's on the left side of the screen. Okay, so we are saying uh, how do I, okay, so let's say frequency equals 80 million. Then if the frequency is 80 million, that's 80 million ticks per second. So then 1 divided by frequency is that. And that, oh, I was actually having another conversation with Gemini about printing these kinds of things. So this is scientific notation. This is basically like saying 1.25 multiplied by 10 raised to the power. Exponents comes before, yeah, okay, so that's fine. Raised to the power negative 8. That's what we're going to get here. I need to figure out a good way to print this. So there are multiple ways to do this. One method is forced decimal formatting. So 10F, okay. Then there's explicit scientific notation. I think the last time I missed the dot. Yeah, I'm not very good with like format strings. I haven't played around with format strings a whole lot. There's very few situations where I actually play around with format strings. In situations where I do need to do any kind of formatting, I'll look up specifically what I need, and that's that. I don't usually do a whole lot with format strings. So actually, no, I should say format specifiers, not format strings. I don't know if format strings would be accurate, but like yeah, format strings are basically, or format specifiers slash format identifiers, format specifiers, I think. It's a way to change the representation of what is being printed. So generally you would use it in something like a print statement in, or a print function in Python, or in a print line function in Rust. And additionally, if you have format methods, like Rust does, I believe within the format method, you can do whatever formatting you need. Yeah, anyways. So yeah, I don't use that too much. Okay, let's store it just for the sake of, having it inside a variable. Um, and we're gonna do print this, this, and that. So we want to do num01 point to e. That didn't help. Let's try the other one. 10f. That helped. Oh, okay. 2.2e is for explicit scientific notation. I wonder what the 2 is meant to be. Can I do 3e? 3e adds, 3 adds another digit after, what do you call it? After the decimal point. Okay, all right. So if we have scientific notation, we can do it like this. So that's our value. Um, Seconds, units. I need to do this calculation real quick, just for the sake of doing the calculation. Give me a table, dude. Okay. So we have decisecond, centisecond, millisecond, microsecond, nanosecond, picosecond, femtosecond, attosecond, zeptosecond. Hold on, is this going like lower or higher? Like what's going on? Value is 10 to the power 1 second. Okay. So that's 10 to the power. Oh, wait, there's two tables here. A decisecond is equal to 10 seconds. A centisecond is equal to, sorry, a decasecond, not a decisecond. Decasecond is equal to 10 seconds. Why do we have these two? Like, so we have something called submultiples. I think that's what I'm looking for. And then we have multiples. So in multiples, you have decasecond, hectosecond, kilosecond, mega. These are bigger. Okay, these are bigger. Okay. Um, Also, I don't often use deca. I just realized that. And that makes sense, right? Deca for 10, because decimal. Yeah, deca makes sense. There's something called hectosecond, and that's 1 minute and 60 seconds. Sorry, 1 minute and 40 seconds, because 1 minute is 60 seconds. 1 minute and 40 seconds. That's 14. 1 minute and 40 seconds. But it says hecto. So that's making me think about 16. And I'm not sure. I haven't dealt with these. Then there's kilosecond, which is 16 minutes and 40 seconds. There's megasecond, gigasecond, terasecond, petasecond, exasecond, zetasecond, yotasecond, ronasecond, and quettasecond. That's crazy. Okay, so we're gonna stick with what we were trying to do. So there's a decisecond. Um, I just realized something. I said decisecond, but decasecond, not decasecond. Though, I mean, which one would be right? Because deci as in decimal, right? Could it be decisecond? I don't know. I don't know. Okay. So, decisecond is 10 to the power negative 1. So, if we have 100 and it's 10 to the power negative 1 second. So, to get the seconds value, if we have nanoseconds, to get the seconds value, we want to do that. So let's say, what's a good way to like practice it? What am I trying to do here? Because okay, what I was gonna do was gonna be like much simpler. It was gonna be like, okay, let me multiply nano by 1,000, and then I'll get milli, and milli by 1,000, and then I'll get second or micro or whatever. But now there seems to be a lot more going on here. Um, okay, well, it's 10 to the power negative 9 seconds, which is kind of interesting because the scientific notation that's given here, the scientific notation that's given here is 10 to the power negative 8, not negative 9. So if we need to be multiplying it by, like, if we are trying to get this in, so it's what, 0.00, so and so, so and so. This is being presented in, this is being presented as 1 second already. I don't know if this is being done right. Hold on. 12, 08 multiplied by 10 to the power negative 9. That just made the situation worse. Okay, let's say 0.0000, I don't know how many zeros there are. 7, I think. 0.00125. Oh, I forgot the 1 there. Yeah, it's not 0.25, it's 0.125. Yeah, that's not working. There's something, I'm confused about something here. Hold on, I'm gonna open up a conversation with Gemini, and hey, I wanna convert um 0.00000000125 ns to seconds. Oh, wait a minute. No, stop. That's wrong. That is wrong. No, that is wrong. It's 12.5 nanoseconds. Hold on. It's 12.5 nanoseconds. Back up. Back up. Sorry, I made a mistake there. I want to convert um 0.00000000125 seconds to nanoseconds, because I'm trying to get that 12.5 nanoseconds. Okay, to convert seconds to nanoseconds, you multiply by the conversion factor, which is 1 second equals 10 to the power 9 nanoseconds. Given the value so and so, multiply so and so. Wait, that's 1 multiplied by 10 to the power negative. Identify the value in scientific notation. Multiply by the conversion factor. Okay, how is this working exactly? So we first identify the value in scientific notation, and in scientific notation, it is what has been mentioned, which is 1.25 e negative 0.8. Okay, fine. After that, we multiply that by 10 to the power we multiply that by 10 to the power um, 10 to the power 9. Okay, multiply that by 10 to the power 9, we get 12.5. Okay, so I'm confused here. How is the scientific notation uh, 10 to the power, let's say 10 to the power 9, sorry, 10 to the power negative 8. However, the conversion factor is 10 to the power 9. It's easy to get those exponents tangled up. The key is to look at them as two different jobs. One describes the size of your specific number, and the other describe. Oh, okay. I didn't think about that. One describes the size of your specific number, and the other describes the relationship between the units. Here's a breakdown of why those two numbers are different. The value, y 10 to the power negative 8. This is just a way to write your specific measurement without all the zeros. Because the decimal point moves 8 places to the right to get behind the first non-zero digit, um, it moves 8 places. So there are 7 zeros. Okay, so we are looking at the value 0 double zero double zero triple zero 125. Okay, so we have 7 zeros and then 125, and the decimal point has to move 8 places. Um, there's something here mentioned about it has to move because the decimal point moves 8 places to the right to get behind the first non-zero digit. We use a negative exponent because of that. Sorry, I zoned out for a bit. Yeah, okay. This exponent is frozen. It just describes how small that specific amount of time is. Then we have the conversion. This is the bridge between seconds and nanoseconds. It's the universal constant that doesn't care what your specific measurement is. So 1 second is a relatively long time. 1 nanosecond is a tiny fraction of a second. That is 10 to the power negative 9. Therefore, um, it takes 1 billion nanoseconds. Holy shit. It takes 1 billion nanoseconds to fill up 1 single second. Okay, okay. Now I get it. Okay, is there a reason why, hold on, are we dropping frames? Oh shit, we are dropping frames. I need to, hold on, I need to pause this. Um, I think we're good now. Hopefully. The connection should have stabilized and we should hopefully be good at this point. I think so. Yeah. Okay. All right. Is there a reason why we move the decimal point to the right side of the first non-zero digit. Also, I feel like I don't fully understand this whole exponent of a negative number thing. And that's true. I actually don't fully understand it. I'm just kind of like going along with it. Because like, okay, when we have positive exponents, if we say 10 to the power, or let's say 4 to the power 2, right? That's 4 multiplied by 4. If we say 2 to the power 4, that's 2 multiplied by 2 multiplied by 2 multiplied by 2. So basically that's 2 multiplied by itself 3 times, but there's four of these 2's in total that are all being multiplied together. Um, but then what's happening in the case of a negative number, in the case of a negative exponent? Okay, those are great questions. Scientific notation can be a bit arbitrary until you see the why behind the mechanics. Why the first non-zero digit? The rule of placing the decimal after the first non-zero digit is purely standardization. Technically, you could write your number as 12.5 multiplied by 10 to the power negative 9, or 0.125 multiplied by 10 to the power negative 7. They are mathematically equal. However, scientists and engineers agreed on a standard form so that comparisons. Okay, so this is because of scientific notation. This rule is specifically because of how scientific notation is defined, or rather, this rule is what's dictated by scientific notation. Right. Comparisons are instant. If two numbers are in standard form, you can tell which one is larger just by looking at the exponent. I did not know that. And then consistency, it prevents confusion when different people are sharing data. It ensures there is always exactly one digit, 1 through 9, to the left of the decimal. I just realized something. There's always one digit to the left of the decimal. I was actually wondering about this. Like, why is it that we are seeing these digits in this specific form? I'm gonna open up a new conversation. By the way, speaking of Gemini, I opened up Gemini CLI for the first time in the past month, I think. I was using Gemini Web for doing stuff, and in that time, Gemini CLI has had a bunch of things added to it. It's had a bunch of, hopefully, things that were broken before have now been fixed, but they've definitely added a bunch of more stuff. Um, and hopefully it's a lot more stable as well. Hopefully I'm not going to be getting that weird, you've used up your daily quota thing because, well, you've used up your daily quota thing. Hopefully I'm not going to be getting that despite not having used the quota at all. But other than that, yeah, they have added a bunch of things. Unfortunately, some of my older conversations are just lost. But I'm going to be honest, I doubt I was going to be going back to them. And the good news is that for some of those conversations, I did agree to let Gemini write them out into markdown files. So now I have those, not the conversation itself, but like the answers to some of my questions. I have them written down in those markdown files. One that I do want to make sure stays alive. I don't know if it's going to stay alive. Even if it doesn't, I can, I have the syllabus. But yeah, one that I do want to make sure stays alive, or I'm hoping stays alive, is the Rust course that I was doing with Gemini. I dragged that on for way too long and left it on pause for way too long. I don't know if at some point the thing just expired, but yeah, there is like an autosave kind of thing, which allows you to resume conversations. So you can see like a list of the other conversations that you've had with Gemini, and you can open up any of those conversations again, even if you haven't saved a single checkpoint for any of those conversations. Okay, that being said, I do want to get back into using Gemini CLI again. And I've made a small change in my plan to learn electronics in general. So, initially, my plan was this: I'm gonna learn how to use microcontrollers, and then so the assumption is that I know how to use microcontrollers, or Gemini is going to make the assumption that I know how to use microcontrollers, and it's going to teach me analog electronics through the use of microcontrollers, which is great. That's awesome, right? I set up that whole prompt. I set up the syllabus, or I got Gemini to set up the syllabus for me, and I was very close to getting started with it. But then I started, diving deeper into microcontrollers because there's a lot that I don't know about micro. Well, I'm a beginner. I knew like nothing about microcontrollers short of letting or making an LED blink. I knew like nothing else. So then recently we started learning about microcontrollers, and in trying to understand how PWM works, I found myself going down deeper into how the ticks are generated, how the clock signal works, how things work on a lower level in the ESP32, and just in general how a bunch of analog electronics stuff is working in the ESP32. Um, and that made me realize that and a couple of other things as well. There are a bunch of projects that I plan on doing where there will be some times where I need to combine circuits, or at the very least join grounds together, and there is a certain level of analog knowledge that I need to have in order to be able to do that properly and safely. A good example would be um, an atomizer circuit, an ultrasonic atomizer circuit or module, which is a 5-volt module, but it operates at a very different current than the ESP32. And then, of course, we have the ESP32 as well, which give me a second. Okay, yeah. The dev board is the dev board takes 5 volts, and the ESP32 itself takes 3.3 volts. But if I'm powering the dev board and not directly the ESP32, I would be giving it 5 volts. It still takes significantly less current overall than the the atomizer module. And if I want to connect both of them together, I need to take into account certain things about how both these circuits work, because while the ESP32 might not cause any sort of interference, it turns out the ultrasonic atomizer module, apparently it creates electromagnetic interference, and that can kind of come back through the ground line to the ESP32 and disturb the working of the ESP32. And to avoid that, I would have to add in a couple of things like a capacitor. That's mainly for filtering the noise, but additionally, maybe to protect from current from one point going into another point where it's not supposed to, I would have to use a diode. And all of this is analog electronics knowledge, right? I don't know any of this, so I kind of feel like this is what's making me think that trying to learn about analog electronics through microcontrollers, this would have worked out if I was okay with learning everything on the higher level with microcontrollers and just leaving it at a higher level. But as I'm learning, as I'm going down to the lower level, I'm well, I find myself going down to the lower level, even in microcontrollers. I'm realizing that maybe I should learn analog electronics as a separate track and learn digital electronics as a separate track. However, learn them both side by side, not have one being dependent on the other. Um, and so, keeping that in mind, my plan to set up that course, the analog electronics with microcontrollers course, I don't think that's going to work out that well. So what I want to do is I want to set up a new course again through Gemini. I'm going to get Gemini to set up the syllabus for me, and this syllabus is going to be for. So I don't need a syllabus for digital electronics anymore. I'm just going to be using this. Actually, you know what? This has me curious. I'm wondering if there's some other site other than All About Electronics, which is what I was using previously. If there's some other sites similar to how we have this Impel Rust for ESP32, similar to how we have this, I'm wondering if there's another site for analog electronics than All About Circuits. So give me a second here. Hey, I'm currently learning analog I'm currently learning uh, about the ESP32 and no STD Rust for the ESP32 using the Impel Rust for ESP32 book. It's super helpful. In addition to this, I would also like to learn analog electronics because my knowledge in that domain is close to nothing. I know very little, more than simple battery, LED, resistor, circuits, and Ohm's law. I know that there's a website called All About Circuits where they have a section. They have pretty much an entire book dedicated to teaching you all about electronics. But I'm wondering if there are any other sources where I can learn about analog electronics um, in a form similar to the book type of thing that has been created by Impel Ferris. Um, the analog knowledge doesn't have to, I don't think I need to mention that. Any suggestions? Um, Perhaps open source alternatives? Okay, this is a fantastic journey to be on. Moving from no STD Rust on an ESP32 into the world of analog electronics is like moving from the conductor of an orchestra to the people handcrafting the instruments. It gives you a much deeper appreciation for why things work or why they glitch. Since you like the Impel Rust for ESP32 book, you likely prefer resources that are hands-on, well-structured, and bridge the gap between code and physical reality. Here's the best book style and open resources. Here are the best book style and open resources for learning analog electronics that mirror the maker-friendly deep dive approach. The Art of Electronics and its Learning Guide. While the main book is a massive reference, the companion book is exactly what you are looking for. Learning the Art of Electronics, a hands-on lab course. This is designed. I don't know. I don't understand what Gemini meant by uh, is a massive reference. But okay, this is designed specifically for self-study. It assumes you know nothing and walks you through the lab sessions. Okay, why it fits? It's famous for its good circuit, bad circuit examples, which helps you develop an intuition for analog design rather than memorizing formulas. Then the interactive alternative, Circuit.js and every circuit. Since you're coming from a software background, you might find playing with electrons more intuitive than reading about them. Falsted's Circuit.js, open source. This is a browser-based simulator. You can see the current flowing represented by moving dots and the voltage level in colors. The book connection. This is a massive library of pre-built circuits that serve as a living textbook, moving from simple resistors to complex op-amp filters. Then we have the Forest Mims notebooks. If you want something that feels indie and open source in spirit, look for, what do you mean open source in spirit? So it's not open source? Look for Forest Mims 3's Engineers Mini Notebooks. They are hand drawn and hand lettered. They feel like a mentor's personal lab notes. They focus on practical building blocks, for example, so and so, so and so. The ultimate open resource, all about circuits, the volume series. You mentioned this, but it's worth noting that this is actually an open source project called the Lessons in Electric Circuits series by Tony R. Something. The structure, it's divided into so and so, so and so. Pro tip, if you, okay, there you go. That was my problem. If you find the website too ad heavy, if you find the website too ad heavy, you can often find the original PDF/latex versions on GitHub or mirrors, which can feel much more like a traditional notebook. I did not think about that. I'm going to Google this real quick. But I also want to look at the other suggestions that Gemini had given. Give me a second here. Uh, so there was the interactive thing. Massive library of pre-built circuits. Falsted.com, circuit so-and-so. Falsted's Circuit.js. Okay, let's take a look at that. Falsted Circuit Simulator. If this is in JS, can I like download it and um hold on, we can draw on this. Add a wire. Okay. Wait, they have like an oscilloscope set up in this as well. Hold on, I'm just gonna connect random things real quick and see what that looks like. It's just a wire. There's nothing consuming anything here. So let's draw a resistor. Okay. Let's run it again. Okay, are there like examples that I can use? This is open source, right? So I could run this. How much what kind of resources is this consuming? If this is all JS, that is, I just need to check what kind of resources this is consuming right now. How do I check that? So okay, around 140 MB. I'm assuming this is the, yeah, if I close this, now that's gone. Okay. So around 140 MB, and then of course for the simulation, it's going to be using the um, for the simulation, it's going to be using the CPU. Okay, all right. Um, Faulted circuit JS. Did I open the right thing? There's circuit simulator, and there's circuit JS. This is the thing that I was trying to look at. All right. Okay. Okay. Can I host this myself? There's circuits over here: Ohm's law, resistors, voltage divider, 555 timer IC. Dude, this is crazy. There's holy shit, dude. This is an entire, this is crazy. There's like drawing options here, and then that entire circuit can also be simulated. It's also really fast. I'm running this on my one of my older machines in the browser. So like I could even draw things if I needed to. Damn, that's crazy. Also, yeah, I need to look at the All About Circuits book. Wait, Faulted Circuit Simulator. This is a version of the original available so and so. Okay. Um, Faulted Circuit JS, GitHub. Give me a second. Okay, Circuit JS 1. It was originally written by Paul Falstad as a Java applet. Okay, all right. For a hosted version, so and so. Okay, okay. There are two hosted versions. One is in lushprojects.com. I like that name. And then there's also falstad.com. Thanks to Edward Calver for 15 new components and other improvements and so on. So, building the web application, the tools needed. Okay, is there like a release thing that I can just directly use? I mean, I don't mind. Wait, deployment for so and so, so and so, so and so. Because if this is, yeah, this is entirely a Java application. So I'm gonna need the Java related tools to build this, and I don't want to have to go through that entire thing. Instead, I could, I mean, I could just use Falsted's website. That works too. It's pretty decent. And it's running incredibly fast as well. Let me just mention that. It is running super fast. It is not slow at all. Um, but yeah, dude. Okay, okay. Analog digital, flash ADC, 555 timer IC, transistors, NPN transistor. Yeah, yeah. What is we can specify the voltage. Oh, it's the base voltage. Okay. This is cool. Like you can like it also follows the speed or the simulated speed, because like with the with the transistor, you give it a certain amount of voltage, then that's gonna quote unquote open the gates, right? But that's even that can be controlled, as in how much the quote unquote gates open. That can also be controlled by how much voltage you are giving it, and therefore how much current you are giving it. Um, and even that is being simulated here. So as you increase the amount of voltage, you'll notice that the amount of current that's flowing from the collector to the emitter is it increases. So this is great. This is awesome for multiple reasons. This is amazing. I'm gonna remember this. I'm gonna keep this in mind. I need to additionally also look for All About Circuits book. All About Circuits book, GitHub. Okay, open electronics. Okay, this is a resource that somebody has made with a bunch of, okay, I should keep this open as well. So there's books, getting started in electronics. Oh, Forrest Mims, that's mentioned here as well. This is this is a book on Amazon. Okay, this is a physical book. Okay, all right. Sorry, I was reading the thing. Then we have the art of electronics. These are all okay. This is a link to physical books. Fine. The videos and courses all about circuits that goes directly to all about circuits. There's Ben Eater's stuff. There's circuits and electronics. Um, oh, okay. The person set this up as PDFs, one for DC current, one for AC current. Then there's another section on semiconductors, another section on digital, something about reference, and then experiments. Okay, okay. Let's open up this massive PDF. And this is, yeah, this is great. Give me a second. I'm just scrolling through this thing. Okay, the entire thing is here. I mean, I might as well just download the PDF and then open it up in my browser so I can read the entire thing. It's basically a copy of that of the stuff on that website. Shout out to this person. I didn't even consider that somebody might have, made a mirror of the repo. Holy shit, we are almost 1 hour into the stream, and, and I'm still doing a yap sesh, dude. Well, kind of limited, connected. What's the word I'm looking for there? Kind of connected to what we are doing here. Um, sorry, kind of connected to PWM and all of the clock signal related stuff. It's connected to that. That being said, this is great. This is awesome. Somebody did create a mirror of this book, and they have put it up on GitHub. And the repo itself is like 11 years old, by the way. Hold on, is this consuming a lot of RAM? Because the PDF itself is showing up as only 4 point something MB. Okay, that is stuck. Yeah, I think I need to close a couple of these things. I think I need to close a couple of these things. Okay, what is this? In this website, I will publish my personal course notes for so-and-so. Oh, that's nice. Hell yeah. Hell yeah. There's something using up. Oh, it's the circuit simulator was one of them. Okay, yeah, sorry about that. I was kind of distracted with a bunch of things, and yeah, I'll come back to this when I get a chance. So the PDF itself is 4 MB, but whatever it expands into whenever it gets loaded, that is a couple hundred MB, I think. I think so. But yeah, I'm gonna keep this as it is for some time, and yeah, yeah. So what are we doing? I'm gonna take a quick break, and then we're gonna continue here. Um, yeah, yeah. I'm just gonna take a quick 2 minute break, and I'll be back. All right, I am back. Let's refresh this feed. Okay, all right. So my main thing with all about circuits was like ads popping up in various places, and that's kind of why I was looking for a different alternative. I would also notice when I would try to load it in a different when I would try to load it, basically, there would be a little too much memory usage going on there, and I was like, dude, there has to be some better resource that I can get this information from. I'm not faulting the person for, putting ads and plugging products and all of that stuff. That's great. You do you, but I'm looking for a different resource where all of these things aren't popping up. So that's why I am looking for all these different places where I can get this information. I'm definitely interested in this thing, the forest mims. Forest mims. Let me just look at that again. Also, there's a bunch of what do you call it? There's a bunch of repos apparently where there's information about electronics related resources. Um, yeah, yeah. Okay, so I can look into hosting Circuit.js later on. For now, um, give me a second. I'm just looking. Okay, the Forest Mims notebooks. So I definitely want to use the Circuit.js thing because this is an incredibly useful tool. It's going to be very useful for me, in terms of learning. Um, and additionally, I need, okay, what is it? The Art of Electronics by Horowitz and Hill. Okay. The Art of Electronics, um, GitHub. I don't know if this is okay. Um, the repo is mentioned here, but in the repo's README, it's mentioned embedded software engineer note. I do not wish to expose my work to AI. If you want to view my code, DM me. Okay. All right. Um, so I guess, wait, contributed to Art of Electronics system modeling. So there, wait, no, that's a different thing. Yeah, okay. We'll look for a different resource. That's okay. I don't even know if it's the same person, but yeah, yeah. Okay, student material for the Art of Electronics PDF. Okay, right. I'm gonna look for this in different places. Um, what was that? Forest Mims. Forest Mims. Getting started in electronics. Book by Forest Mims. GitHub. The thing is, I don't know which of these are meant to be open source and which are which are being pirated and put onto GitHub. Okay, getting started in electronics by so and so. This is a PDF. Okay, 12.6 MB. Holy shit, Gemini wasn't kidding. This entire thing looks handwritten. And it's like, you know how we had those notebooks back in the day? We probably still have them. But like back in the day, we had these notebooks where they had like lines and you would write your sentences within those lines. Um, this book is being presented in that way. Each page is being presented in that way. Okay, let's take a look at the contents. Getting started in electronics, we have electricity, putting electricity to work, back to basics, static electricity, electrical current, direct current electricity, alternate current electricity, measuring AC and DC, electrical circuits, pulses, waves, signals, and noise, and so and so. Um, you know what? Yeah, I think I'll just use this resource. Great. Awesome. Yeah, I think I'll just use this resource. Jumping is going to be a little bit complicated. Jumping pages, I mean, it's going to be a tiny bit complicated. Also, I don't know how well I'm going to be able to read this entire thing. I wonder if this, dude, I wonder if this was written on paper first, and this person then like digitized the copies. Because that would actually be really cool if that's what happened. Like, sorry, I'm missing my words here, but yeah, I wonder if this was written out on paper first, like in that form, in a notebook, exactly like that. This was handwritten, and it's not just a handwritten style, but like this was actually handwritten. I wonder if that's the case. And then, all that handwritten stuff was then later digitized. Because they have like diagrams and stuff as well, which all looks hand drawn. This is really cool, dude. You know what? We could, if I download this PDF and try to open it up in TDF, I wonder if the Firefox PDF viewer has like a dark mode option or an inversion option, because TDF, the terminal PDF viewer that I have installed, that has the option to invert the colors. So it doesn't necessarily give you a dark mode, but because a lot of PDFs tend to be white and well, they tend to have a white background and the text tends to be black. So if you just invert the thing, then you've created dark mode. The downside of that is because you're inverting it, so anything that's in color, the color is going to get inverted. So any images that might be there, they're suddenly going to start to look like negatives. If you remember negatives from back in the day, they had like a very specific inverted color style. That's just one of the downsides of it. But other than that, it gives you a pretty decent, you know, it gives you a pretty decent, what do you call it? It gives you a pretty decent like dark mode experience. Though, okay, in this case, the great thing here is that there's like no color going on. Even the diagrams. So the page is white, the lines are black, and everything else, the text, the drawings, which again, they look hand drawn, um, the text and the lines and everything is black. So if I just invert this, then I'll have a pretty decent dark mode experience. The only downside with TDF is that it can be pretty heavy on the RAM. So loading up a PDF easily. easily it can go into like 1 GB, 2 GB. So that's just one of the downsides. But other than that, the PDF viewer is great. I'm also remembering that I don't have the patience to sit and read all of this. I just remembered that. As amazing as this is, I literally just remembered that one of the other reasons why I didn't stick with the all about circuits thing was because if something is not stimulating enough for my brain, then I'm going to start to get distracted. And if there ends up being like way too much to read before we can get to the action, quote unquote, then I'm going to start getting distracted. I'm still just going through these pages. Sorry, I'm not doing it on stream. I'm doing it on a different machine, so you guys can't see it. I'm not doing it so you guys can't see it, but you guys can't see it because I'm doing it on a different machine. Okay, circuit diagrams. Thus far, the electrical circuits shown in this book have been illustrated in pictorial form. Pictorial versions of circuits will be used in the next several chapters. Later in the book, the pictorials will be replaced by circuit diagrams. In a circuit diagram, pictorial views of components are replaced by component symbols. Dude, this is crazy. The the fact that like this entire thing, it's like handwritten. I need to confirm this, dude. Cause like holy shit. Give me a second. I'm just asking Gemini a question here. Um, okay, I have NeoVim open. Oh yeah, I do actually. Let me take care of that. Holy shit, today's stream, even though I started on time, it's not going in the direction where I thought it's gonna go. There's just been a whole lot of yapping on my end, and we didn't necessarily do anything. I mean, it is what it is. I'm this research also later on it's gonna help in the stream because the analog electronics stuff that I want to do, that's I'm gonna be learning that on stream. So um okay. I just came across the Forest Mims uh, getting started in electronics course. Um, Someone has posted it to GitHub. First off, I'm wondering if all of that is actually hand drawn and then digitized later. Also, is this meant to be open source? This is just for my curiosity. Okay, that machine kind of ran out of RAM, and yeah, we're trying to free a bunch of RAM on there. So give me a second here. Okay, yeah. In the meantime, I guess I can continue talking about what I'm planning on doing in terms of both analog electronics and digital electronics. So, okay, new plan, because the previous one, once I tested out the thing practically, I realized that it's not going to work out. I need to learn both analog and digital electronics as separate tracks, um, probably simultaneously. Yeah, probably simultaneously. I wonder if learning them simultaneously is gonna help me. Um, is gonna keep my mind stimulated enough for me to be able to make progress in both tracks. Yeah, I wonder if I can do that. Just a second here. Just doing something. But yeah, you know what? This Forest Mims one is interesting, and of course, the All About Circuits one is also super interesting. I did read a couple of those chapters. That is, let me tell you, like aside from like because I didn't want to view the thing on the website, but let me just tell you that book, the amount of detail that that book goes into is insane, and like it holds your hand in terms of teaching you analog electronics, and not just analog, it's electronics in general, because it teaches you, it starts with analog because everything starts with analog. It starts with analog, starts with the basics of electricity. It then moves on to DC and AC, and then it focuses on DC, and then it also has a separate section for AC, and you can like choose which section you want to focus on. I'm not going to be focusing on AC at all because AC is just not something that I do. I would prefer to stick to DC and just stay within that lane, at least for now. The majority of the stuff that I plan on doing is going to be is going to be DC. Anything that is AC is probably going to be converted to DC before I can do something with it. So I don't want to touch DC. Sorry, I don't want to touch AC for the time being. Um, and I feel like I'm gonna have my hands full with DC alone because there's so much stuff. And then it later goes to the digital side as well. Within that book, there's a separate section which teaches you about digital electronics, and there it goes into stuff like microcontrollers and the concept of things like flip-flops and logic gates and all of that stuff. I think it also most likely it covers stuff like CMOS as well. So there's going to be a bunch of very interesting stuff to explore there. I'm guessing the clock signal thing that I was having trouble with, that probably gets covered uh, in that section as well. Maybe, maybe. My main thing with trying to learn analog electronics is not to learn all of analog electronics, but to learn at the very least the basics to be able to make basic to intermediate level electronic circuits with discrete components and ICs. So, like putting together resistors, capacitors, LEDs, timer ICs, um, transistors. Did I mention capacitors? I don't remember. Diodes and whatever other such discrete components are there, putting them together to create a working circuit and understanding how the current is flowing through the circuit, where the current is going, um, and where the current ends up as well. Where the current is flowing through the entire circuit, how the current is flowing through the entire circuit. I want to know that because that kind of knowledge, that kind of information is going to help me with more complex circuits. Because this whole thing about like electromagnetic interference it has made me realize that okay, there's a bunch of things that I need to learn in analog electronics that I don't know anything about right now. Give me a second. I'm just going to freeze the matrix rain for a little bit. Okay, Forrest Mims Getting Started So-and-so is a legendary text in the maker community, and your observation about its unique look are spot on. Okay, is it actually hand-drawn? Yes. Every page of the book, including the text, the circuit diagrams, and the illustrative characters, was meticulously hand-drawn and hand-lettered by Forrest Mims III himself. Who is Forrest Mims? Let me give me a second here. Okay, Google says American columnist. I haven't heard the term columnist in a while. This was like from the days of newspaper and magazines and stuff. Forrest Mims. Forrest M. Mims is an American magazine columnist and author. Mims graduated from Texas A&M University in 1966 with a major in government and minors in English and history. Okay. Okay, so this book, hold on, let's continue reading. Mims used a fine point pen on graph paper to ensure the alignment of the text and components. The quote unquote engineer's notebook style was a deliberate choice to make the subject matter feel approachable and less like a dry, intimidating textbook. After completing the physical pages, they were photographed and scanned for traditional printing. Modern versions you see on GitHub or archive sites are high resolution digital scans of those original physical pages. Is it meant to be open source? No, it is not open source. While the book is frequently shared on GitHub, the Internet Archive, and various PDF repositories, it is still under active copyright. Copyright status: the book is copyrighted by Forrest Mims III. It was originally published so and so. Availability: because it is so beloved and has been out of print, in various formats over the years, many people treat it as abandonware or community property, but legally it is a commercial product. Wait, if it's out of print, people would have trouble getting their hands on it unless they're getting it from someone else who bought the thing previously. So right now, even if people wanted to buy it, they wouldn't be able to buy it. Okay, support the author. Forrest Mims is still active today. If you find the material valuable, you can buy physical engineer's notebook editions or spiral bound. Wait, okay, so copies are available. Wait, engineer's notebook is a separate thing than um, getting started with getting started in electronics. Okay, let's continue reading this. You can still buy physical engineer's notebook editions or spiral bound copies through major retailers like Amazon or specialized electronics hobbyist shops like Adafruit and SparkFun. Wait, out of curiosity, is that specific book still? Because, like, okay, at first I was like, yeah, even if people wanted to buy it, they wouldn't be able to buy fresh copies. They would be buying it from somebody who has already bought it. But I didn't think about the fact that what about copies that were printed but didn't sell? So people might still be holding on to those copies years later. It's not just personal, bought copies. It could be these these retailers that bought it who are who can now sell it. Is that specific book still um, being produced and available for sale or not? Because you mentioned the engineer's notebook, but I'm not sure if the book I asked about is this same book or maybe a small part of this book or something else. Okay, to clear up the confusion, yes, the book you found is still very much in production and available for sale today. Why was it mentioned that this thing is out of print? So it says here because it is so beloved and has been out of print in various formats over the years, many people treat it as abandonware or community property. Okay. It is a distinct standalone book, though it belongs to the same famous family of hand-drawn works. It is a distinct standalone book. Okay, okay. Here is how it fits into the Forest Mims library. Getting started with so and so, that's the book you found. This is the flagship title. The content, it is 128 pages long and is designed as a complete self-contained course. It starts with the absolute basics, static electricity, magnets, etc., and moves through components and logic gates, ending with 100 projects you can build. Okay. Current status, it is still published by Master Publishing. You can buy it brand new as a physical paperback or spiral bound from retailers like Amazon, Adafruit, and SparkFun. The look, this is the one you saw on GitHub and the graph paper background and with the graph paper background and the little electron characters running around. How it differs from the engineer's notebook. The engineer's notebook series is related but serves a different purpose. If getting started is the textbook, the notebooks are the reference manuals. You know what? That's good enough for me. Yep, that's good enough for me. Okay. Right. So at this point, I need to decide which of these resources I want to start with, or if I just want to get Gemini to generate the course for me. I want to give that a try. I want to give that a try. I want to see because if I ask Gemini to explain this to me, I feel like it's going to be explained in a much more concise form. Yeah, I don't know. I don't know. I'm gonna have to see which one I want to go with. Okay. Now, other than that, what else were we gonna talk about? Because I feel like we are now ready to look at these formulas. I feel okay. You know what we can do? We can read this entire section again. We stopped here in terms of reading this book, right? Wait, hold on. We can get the matrix rain going again. Okay. So we stopped at this page. We can say basically that we stopped at this page. Also, now that I'm looking at this, it's making a bit more sense to me because now that I've actually explored the various clocks that are available, now sorry, now this is making a lot more sense to me. Looking at these names, I still haven't played around with RC Fast Clock and RefTick. One of these is meant for like very um, low power setups, and the other I'm not sure. Okay, all right. Yeah, dude. I'm still trying to decide if I want to go the Gemini route or if I want to, because like okay, I'm gonna be giving Gemini this entire story, this entire backstory, uh, explaining the whole thing. That yeah, I learned electronics previously. I learned analog electronics, and then later on I got into microcontrollers, and I kind of pushed analog electronics to the side. Give me a second here. All right. So yeah, I'd made this prompt. I can give it a try. Because I'm just gonna get Gemini to or Gemini CLI to generate a syllabus for me, and then I will try going through that syllabus. The syllabus is not going to involve microcontrollers at all, which is making me wonder if I should even mention microcontrollers at all. Or I could give this entire backstory and then tell Gemini to just pretend like I don't know anything about analog or digital electronics. But then at that point, why am I even telling the story? I could just tell Gemini that you are a tutor, teach me analog electronics. Um, we'll start from the basics, going into some of the more advanced things. Um, though, okay, I do need to mention that I want to focus on DC specifically. We can touch AC, but just for knowledge sake, practically, I want to be practicing DC stuff, not AC stuff. To be fair, practicing AC stuff does get a little bit complicated as well, because a majority of the stuff that I'm doing is DC. The only thing that I have that's AC is what's coming out of the wall socket, and you know, I'm not going to be touching any of that. Sorry, uh, got distracted. But yeah, okay. So there's this entire story. So and so, so and so, so and so. Um, I also gave this additional backstory of how I asked Gemini to generate so and so thing. And oh, this was actually not part of the prompt. This was I was explaining to Gemini in like Gemini Web that this is the problem that I'm running into, and what do you think I should like? How should I proceed with this? Because what I'm thinking currently is analog electronics and digital electronics as two separate tracks, not one depending on the other. Learn both of them as two separate tracks um, simultaneously. And well, Gemini kind of agreed and gave a couple of, um, gave some additional information of why that might be helpful and how stuff is taught even in like actual, engineering schools and colleges and stuff like that. Um, yeah, so I think I'm gonna create a new prompt. I also gave this list of components that I have because like when I'm asking Gemini to generate this what do you call it this course for me, there's definitely going to be practical examples. I should also mention I have a multimeter. Yeah, I should mention that I have a multimeter with me. Though I don't know. Yeah, I don't know if I should. I mean, okay, the multimeter is very useful, specifically because these are circuits that don't involve, microcontrollers. So I can just start poking the multimeter into various sections and get a reading. Um, I feel like that would be helpful. I feel like that would be helpful. So maybe I should add that to the list. Um, and maybe in brackets I can mention, okay, a multimeter, though I don't know to, well, I shouldn't mention that. I shouldn't mention that. I kind of know how to use the multimeter because, see, this is the thing about me learning through Gemini. It's that I'm not completely new to the subject. I'm trying to fill in the holes in my knowledge and then also build up new knowledge. So I'm not a complete beginner to it, but like there are holes and gaps here and there in the information that I have. There are also curiosities that I have. Um, sorry, zoned out. Okay. Right. Yeah, back to this thing. So the first time we read this page, I was completely confused about what's going on. I was barely able to make sense out of anything. This thing, clock source, didn't make sense to me, and so none of these things made sense to me either. These are the clock sources. These are basically the clock sources. The interesting thing is apparently they get their, I haven't looked into the others, but like they're all getting their clock signal from somewhere, right? APB clock is getting its signal. There's actually some reading that I have to do with Gemini on this because it turns out APB clock is getting its signal directly from the CPU. Actually, we have the PDF open here, right? Did I close the thing? I need to, oh, no, okay, we're good. So this is the clock. In here we have clock source, all right. CPU clock, peripheral clock. Peripheral clocks include APB clock, RefTick, LED-C, LED-CS clock, APPA, holy shit, APLL clock, and PLL F160M clock. Okay. Peripheral clock usage. So we can use the APB clock for basically anything. And then the others can be used for only very specific things. You can't use it for everything. LED PWM, that's mentioned here for um, RefTick and LEDCS clock. But yeah, okay, for now we're going to be sticking to APB clock. Is there information given? Yeah, there is. Actually, they've given information on all of them. We can read all of them. Okay, so APB clock, the APB clock is determined by the CPU clock source. So APB clock is directly linked to the CPU clock. Though, okay, where is it getting the signal from? I think this is something I need to understand. Yeah, I think this is something I need to understand because Okay, this has to be separate hardware, right? The clock itself has to be separate hardware, like individual separate hardware, because let's say we have xtal, okay? We have the xtl clock, which is our 40 megahertz clock. That's the crystal oscillator, is generating a clock signal at 40 megahertz. This gets fed into the PLL clock, or the PLL, which means that the PLL clock, I guess the source is called the PLL clock, but then the thing itself is called the PLL. So the PLL is going to take this XTL clock source, this XTL clock signal, and clock it up to 320 or 480 megahertz. Sorry, zoned out. Okay, so the crystal generates the thing, right? And then that gets fed into the PLL. Now the PLL has like it amps it up to 320 or 480 megahertz. Great. From there, it can go to the CPU. Um, but for the CPU to use it, it gets divided down. So it becomes, I don't remember the figures, maybe 160 and 240 or something along those lines. It's definitely not 320 and 480. I remember that. At least in this case, it's not. So we have, let's say, 160 and 240. Okay. That's the CPU clock now. The APB clock can be pulled from different sources. No, no. The APB clock is, how am I supposed to be looking at this? Because like, okay, I think what I'm confusing here is the difference between the logic and the actual wiring. So okay, it says here the APB clock frequency is determined by CPU clock source, meaning what we have set the CPU clock source to be. The CPU clock source can be set to one of these values. Um, Actually, that's right, right? I believe so. Yeah, it says PLL, APLL, XTL, and RC fast. Um, that's right. Okay. Sorry, got distracted. Okay. So we have the APB clock, the APB clock, frequency. It's not the it's not mentioning the source, is it? Hold on. Wait. The APB clock frequency is determined by CPU clock source, and this is what I was having a conversation with Gemini about this, and because I was kind of confused about whether it's coming from the CPU or if it's coming from Xtal directly, or maybe it's even coming from the PLL. I was confused about like which one it's coming from, and Gemini mentioned that there's a difference here because i- it's it's coming from, I forgot what exactly Gemini had said, but it was something along the lines of they try to make it seem like it's coming from Wait, I'm trying to remember because my thing was I was kind of confused about this. Hold on, maybe I wrote it down in Scratch. Yeah, this is what I'd asked Gemini. I was like, okay, is this the line that's followed? Like, is this how it's going, or is it that the PLL goes to both CPU clock and APB clock separately? And Gemini said that one of them is true, but then the idea is to make it seem like the other one is true. If that makes sense. Like they try their best to abstract away that detail, and you shouldn't really need to worry about it. I haven't finished reading that. Actually, maybe I could go back to that conversation. I don't know if I have that thing loaded. Give me a second. Reading and printing. Okay, maybe it's this. Yeah, hold on a second. I'm just gonna load up some of these tabs and see if. Sorry, it's taking a little bit to load the tab for some reason. Um, yeah, I'm just waiting, and it could turn out to be the wrong tab as well. Um, yeah, I don't know. Yeah, I'm still waiting for the thing to. Okay, so are you so and so? Do we manually set up CPU clock source, or does it get set automatically depending on certain criteria? This was also one of the conversations I was having. Hold on, so where exactly is APB clock getting its signal from? I'm assuming that gets scaled too, just like so and so. Okay, that is another conversation. Sorry, I'm trying to find this conversation and my system is being super slow right now, and yeah, things are just going so slow. Hey, so I'm kind of confused here. In another convo that me and you are currently having, you told me that I think this is the one. You told me that APB clock is derived from the CPU clock. Yet here you are telling me, yeah, this is the one. I found it. Yet here you are telling me that the APB clock is derived from the PLL to avoid dependency on the CPU clock. Am I missing something here, or is some of your info inaccurate, or maybe there's some nuances or something? You've got a sharp eye for the details, and you've got a nuanced simplification that often trips up people when, sorry, that often trips up people when they read the technical reference manual versus looking at a conceptual diagram. Uh, the short answer, technically, the APB clock is derived from the CPU clock. The confusion usually stems from the fact that the hardware works very hard to make them act as if they are independent. Here's a technical breakdown of the chain versus the result. The physical chain, the topology, if you look at the official ESP32 clock tree, figure 5 in the reset and clock chapter, and so, the path is a serial chain. Figure 5, let's take a look at that. Hold on. So, what are we? So, we have 4 and we have 5. Is this figure 5? says 7.2. I'm assuming this is figure 5 because this is, hold on, is there something in 7.1 maybe? No, this is 7 point, this is not figure 5, that's for sure. So 7.1 is the reset, 7.2 is the system clock. We are looking at the system clock. So this is 7.2 figure 1. Okay, okay. Figure 1 and then figure 3. Figure 2 was somewhere here. Yeah, that's figure 2. 3, 4, and then 5. 5 is ref tick. Okay, all right. Ref tick is derived from, oh, that's crazy. Ref tick is derived from APB clock. The APB clock frequency is determined by the CPU clock source. The ref tick frequency should be fixed. When the CPU clock source changes, users need to make sure the ref tick frequency remains unchanged by setting a correct divider value. All right, okay. So back to what Gemini is saying. If you look at the official ESP32 clock tree, figure 5 and so and so, I love that Gemini is giving me this, the like specific thing, though it doesn't mention clock tree here. However, it does mention figure 5 and reset and clock. So this is figure 5. All right. Um, the path is a serial chain. So it goes xtal to PLL, PLL to CPU clock, and CPU clock to APB clock. Physically, the APB clock is generated by taking the CPU clock and running it through a secondary divider. There is no separate wire going from the PLL directly to the APB bus that bypasses the CPU clock selection. Okay, all right. The independence nuance, the logic. The the reason the words the reason it was described as avoiding dependency is because of how the ESP32 handles its dividers. In most microcontrollers, if you double the CPU speed, the peripheral speed doubles too. But the ESP32 has an automatic dynamic divider. If the CPU equals 240 megahertz, the hardware sets the APB divider to 3. So 240 divided by 3 is 80. If the CPU equals 160 megahertz, the hardware sets the APB divider to 2. So 160 divided by 2 is 80 megahertz. And if the CPU is 80 megahertz, then the hardware sets the divider to 1. So 80 divided by 1 is 80 megahertz. Okay. Because the hardware and the HAL automatically adjusts this divider to keep the APB at exactly 80 megahertz, it effectively isolates your PWM and UART from changes in the CPU speed. To a developer, it feels like a parallel branch because the APB clock remains a rock solid 80 megahertz, regardless of whether the CPU is at 160 or 240. The gotcha, where the dependency matters, the reason the TRM defines it as a chain is because the APB clock cannot be faster than the CPU clock. If you decide to save power and clock your CPU down to 40 megahertz, running off the Xtal without the PLL, your APB clock must also drop to 40 megahertz or lower. It cannot stay at 80 megahertz if the source, that's the CPU clock, is only 40 megahertz. Okay, all right. I have some questions that I need to ask right now to Gemini immediately before I forget all of them. However, I do need to end the stream right now. I'm going to continue looking for ways to start my or restart my analog journey. I very much want to try the Gemini route, if I'm being honest, because the Gemini route gives me the option to it gives me the option to, sorry, got distracted. The Gemini route gives me the option to ask questions based on what Gemini has just told me. But yeah, I need to see how I want to go about this. I could try reading that Forrest Mims book, and if it's able to hold my interest for long enough, then maybe I might not need to do the analog thing through Gemini, and I can just learn directly from the Forrest Mims book. Shout out Forrest Mims for writing this amazing book, because holy shit, the entire thing is handwritten and hand drawn. That's insane. That is crazy. 100 and something pages, 120, I think, 180, I don't remember. 100 plus pages of all of this amazing knowledge. That's crazy. That is insane. But yeah, I do need to end the stream right now. I'm going to try and start the stream earlier tomorrow. Let's see if that happens. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.